The Cheat River watershed was once a hotbed of recreational activity, including whitewater rafting and trout fishing. Pollution from growing mining operations within the watershed began to lower the overall water quality, and over the course of the 20th century, as the basin's water quality began to noticeably decline, these local recreational industries suffered. This decline would come to a head in the middle of the 1990s. Coal mining in West Virginia began before the American Civil War, but it wasn't until the end of the 19th century that it became a major industry. Northern West Virginia became a hotbed of coal mining activity due to the quality of the coal and its proximity to major waterways that flowed north into the city of Pittsburgh and its booming steel industry. As mining operations continued to grow into the next century, there were major economical benefits for the region, but mining also brought with it many environmental concerns, most notably acid mine drainage, or AMD. Thousands of kilometers of streams in West Virginia now suffer from impaired water quality due to acid mine drainage, and as these streams drain into rivers, the larger watersheds are affected. T&T Fuels Incorporated operated several mines within the Cheat River watershed. In an attempt to cut costs, the mine operator drilled boreholes from active mines into nearby abandoned deep mines to drain AMD-affected wastewater. In April 1994, pressure built up by the stockpiled water in the abandoned mine caused the side of the mountain to blow out, releasing millions of gallons of wastewater into nearby Muddy Creek, a tributary of the Cheat River. A similar incident occurred in March the following year at another T&T mine, this time affecting Spilot Run, which was at the time considered to be a pristine watershed. The damage caused to the riparian ecosystem by these disasters brought much attention to the area, and in 1995, the American Rivers Conservation Group placed the Cheat River at number 8 on its list of the 10 most endangered rivers in North America. The blowouts also brought the attention of the Environmental Protection Agency, the FBI, and many state and local stakeholders, who came together and founded the Friends of the Cheat River and the River of Promise Task Force in order to address the AMD problems within the watershed. The Cheat River Basin is approximately 1,435 square miles in area, with numerous active mine permits as well as many abandoned and bond forfeiture mine sites. As of 2018, there are 99 active reclamation sites within the basin. Acid mine drainage occurs when mining operations expose heavy metals, most notably ferrous oxides, often found in coal seams, with oxygen and water. A series of chemical reactions occur that result in the creation of iron hydroxide and sulfuric acid. As the acid is created and the pH level of the water decreases, its ability to carry dissolved heavy metals increases, allowing for transport of larger amounts of iron, manganese, and aluminum. If this water enters the local watersheds untreated, it affects the water chemistry of the stream and can have disastrous results to the riparian habitat. A 1997 USGS report sampled 8 of the Cheat River's main tributaries and found that all but one exhibited evidence of severe acid mine drainage effects. These 7 had very high concentrations of both total and dissolved iron, manganese, and aluminum, as well as pH values below 3.5. Most local riparian ecosystems begin to experience stress as pH lowers below 5.5. pH levels as low as 3.5 would have substantial negative effects on local micro and macro invertebrates and provide an unsuitable environment for fish.
Below the mouth of Martin Creek, Muddy Creek is dead. There's absolutely no living organisms in Muddy Creek below Martin. Upstream of Martin Creek, roughly 12.2 miles, it's a viable fishery. We've got a healthy trout population, partly due to the stockings of a local hunting and fishing club upstream. But as I said, downstream is dead.
As the affected water flows downstream through the tributaries and empties into the main stem of the Cheat, the pH levels drop, causing a decrease in the capacity of the water to hold heavy metals, and they begin to precipitate out. These precipitates can cover the stream and river bottom, inhibiting the growth of algae and other riparian plants. In 1999, the West Virginia Department of Environmental Protection conducted a survey of benthic macroinvertebrates to assess habitat health within the watershed. In the northern reaches of the watershed where the most mining occurs, 24 sites received a bioscore of less than 50, requiring them to be listed on the state's EPA 303D list. An additional 41 sites in the same region exhibited no benthic macroinvertebrates at all and were considered dead. Shortly after its inception in 1995, the Friends of the Cheat organization helped to form a coalition of state and federal agencies, academia, industry, as well as citizen and conservation groups they called the River of Promise Task Force. The ROP wanted to initiate a grassroots movement that attacked the problem of AMD watershed wide. Since 1995, ROP has held quarterly meetings to help initiate and coordinate AMD remediation projects in the Cheat River watershed. Funds from the EPA's 319 Non-Point Pollution Program, as well as the National Mine Lands Reclamation Center, the Abandoned Mines Lands Program, the West Virginia Department of Environmental Protection, and more recently, a local energy company, have been used to construct a variety of both active and passive treatment projects. The crown jewel of these projects are the dual active treatment sites located on Muddy Creek near the now defunct TNT mine sites. The Muddy Creek AMD plant is capable of treating up to 4,200 gallons per minute using a high-density lime slurry mixture that treats acidity and forces metals to precipitate out of the water in two 80-foot clarification tanks. The sediments are then pumped back into the mines and the clean water released into the creek. The plant, which is not located on a mine site, receives water pumped in from several abandoned mine sites and some of the nation's largest bond forfeiture sites, including the TNT mines. The Muddy Creek AMD plant was not enough. An abundance of abandoned mines continued to pollute the Cheat River through Muddy Creek. The West Virginia Department of Environmental Protection and the Department of the Interior petitioned the EPA to grant the country's first watershed-wide NPDES discharge permit. This permit allowed for treatment at multiple sites in the Muddy Creek Basin to function under one permit, with one regulatory sampling site at the mouth of the creek. This made it possible to treat the stream directly. The use of an in-stream lime slurry doser at Muddy Creek allows for the treatment of several AMD discharge sites in one location. The combination of these treatments has shown vast improvement in the water flowing from Muddy Creek into the Cheat's main stem. Measurements taken at the creek's mouth just before the systems came online in early 2018 showed iron measured at an average of 54 milligrams per liter with an average pH of 3.75. Measurements taken 2 weeks after treatment began showed the average numbers of 3.2 milligrams per liter of iron and a pH of 7.08, an improvement of close to 90%. The work by the River of Promise Task Force and all their partners has allowed for the pH in the main stem of the Cheat River at its northernmost point to maintain an average pH of 6.6, allowing it to be removed from the state's 303D list. It is estimated that between 2000 and 2013 that over 1.7 million pounds of AMD waste has been removed from the watershed. While studies of the improvement of macroinvertebrate habitats have shown inconsistent results, multiple indicator mollusk and crayfish species have returned to areas of the watershed. Cheat Lake and much of the river's main stem also show large increases in populations of trout and walleye. The EPA now considers the Cheat River watershed one of the nation's non-point pollution treatment success stories.